Okay, we're back after a week. Okay, so yeah, it's been bless me. Oh. So I haven't recorded like in a week. The main reason is I'm sick right now. I have cold, just like fever, and I'm coughing. So yeah, that's why I wasn't recording. So let's just open this. I was just searching some stuff. Like botany. Yeah, this is a good web if you wanna, practice typing. So it's a good website. You can check it out. It's called Monkey Type. Another one, I think it's called fastest 10. Fastest 10 finger. Oh. Ten fast fingers. Yeah, this one. You can also go on this, or you can go on what was it called? Typeracer. Yeah, Typeracer. You can check out Typeracer too. These are like good webs that you can use for practicing. What's the first one? First link. Yeah. Botany. I was just looking at botany because I hate botany. I don't like botany that much. Okay, I hate it. I hate botany because it's confusing. Enough of me talking. Let's see which one just showed. Okay, this is the chemistry one. I need to start revising chemistry too. We're gonna start with this is physics. Where's the biology? The biology is just here. Here it is. This is biology. This is not bio. What? This is physics. Okay, this is. No. This. Okay, last we studied central dogma. There are 3 different central dogmas given by different people. There's one-way flow, there's circular flow, and then there's I don't know what the exact name is, but we can just call it as reverse transcription. I don't exactly know the name of the flow. The one-way was given by Crick, the circular was given by Commoner, and the reversed one was given by Edgeman and Baltimore. I don't remember the years in which these discoveries or this these things were theorized, but you don't need to remember the years of these things. But I would really appreciate if you guys could just it's good for you guys if you know the years of important ones, not these ones are not that important. I'm really hungry. It's 11:35 a.m. and I'm drinking Fanta and having Cool Ranch Doritos. But I was really hungry. I'm hungry. Okay. So today, according to your NCERT, let's get the NCERT out. Back. Oh, this is the class 11. Where's the class 12 NCERT? Okay, it's in the back. Oh, okay. We're gonna leave this part. We're gonna come back to this after we have completed the entire thing, because it's not related. It's just backing of DNA helix, how DNA helix is packaged, because it's long. DNA helix, it's really long. So how it's packed into the nucleus. Oh boy. So we're gonna start with the search for the genetic material. Well, we do know Mescher discovered the DNA. He couldn't, he wasn't able to, break it down and, simplify it, but because of lack of technology, that's the main thing. He discovered it in the 1868 something. I don't know the year. I'm not good with these. That's why you need like a cheat sheet or something. It's the scientists and their researchers. In 1869. Oh, I was close. I was close. Okay. You guys can see, right? We're in this part. By Mescher and the proposition for the principles of inheritance by Mendel were almost at the same time, but that the DNA acts as the genetic material took long to be discovered and proven by 1926. The quest to determine the mechanics of the genetic inheritance had been reached at the molecular level. Previously, discoveries by Gregor Mendel, Walter Sutton, Thomas Hunt Morgan, and numerous other scientists had narrowed down the search to the chromosome located in the nucleus of most cells, but the question of what molecule was actually the genetic material has not been answered. So, see, nucleus contains a lot of things. Nucleus just doesn't have solely DNA. There are a lot of things that inside, a cell, and if you further break it down in the nucleus, there is still a lot of stuff. So, they didn't know what was actually carrying the genetic material. What exactly is it DNA molecule? Because they didn't know. We now know it's the DNA molecule, but they didn't know back in the day. It might have been RNA. So they did their researches and tried to narrow it down. What was the actual thing that was actually carrying all of this out? So they performed particular different experiments, which gave us the result. Uh, Pencil and what else? Just a pen. Okay. In 1928, okay, we are gonna discuss the Griffith experiment. Get your notebooks out. For all these, like, there are different experiments, and there's a particular sequence that you need to follow. In these experiments, you just can't, interchange the sequences. These need to be carried out in a particular order. So it would be really good for you guys to just make some short note or some sort of flowchart. That's how I like to do it. Sorry. Oh God. This is the bacteriophage experiment. Don't know exactly what. Okay, I don't know what, how carried out. So yeah. There is DNA versus RNA. Then there is chemical properties. Why DNA is, a superior genetic material compared to RNA. Why DNA is exactly. Because there's a particular criteria that a molecule needs to follow to become, a good genetic material. DNA follows all those things, basically has all those things, so that's why it's much better compared to RNA. We're gonna get to this. After that, we have the RNA world. There is replication. Then there is the experimental proof of replication. This experiment was carried out by Messelson and Stahel. There's also this DNA is semi-conservative in nature. This experiment looked into. There is the machinery and the enzymetry. Again, need to make short notes of this because there are some, terms that you need to know. Here's also this is an important part because sometimes they do ask questions from this part because people ignore it. It's about Taylor and Vicia Faba, basically faba beans. She carried out an experiment. This was just like this. This experiment proved that DNA is semi-conservative in nature. This proved the same thing. It's just a small power, so. Then there is the transcriptional units, the regions and everything. What is exactly transcription? Then there are different types of transcription in both eukaryotes and prokaryotes. The genetic codes. You don't need to know all this, but you do need to know the majority ones. Sickle cell anemia. Oh, you guys, I haven't taught you guys the previous part. So, I'll give you a brief about this. I will tell you. Then there is mutation. There's tRNA. If you want, you can study tRNA from, what's this book name? MTG. Yeah, they have good diagrams. It's a bit. They do have a lot more details. That's why if you want to study, yeah, it's good for you. Because it's a lot more clear. The Clover model, like here, it's much more clear compared to this abomination. Then there's Lacoperot. After that, there is, Human Genome Project. For that, just go on YouTube. I'll tell you. Okay, Shabby. Oh God, what? Okay, just enter. Just go here. This is a good vid that you can check out by National Human Genome Institute. So, or you can go on Few School, Global Education. Yeah, TED also has a good TED Education. They also have a good one. If you want to know about, like, if you want to study human genome, just go on the original channel. You see.
Are you an early bird or are you a night owl? Have you ever wondered why?
I don't sleep,
Well,
so
it has to
I'm.
do with your
Oh,
circadian rhythm. And according to new
bro,
research,
come on! I don't want to get copyright strike. Oh, God.
It turns out that yours.
Okay. For that, just go on there and check some videos out. DNA fingerprinting, same. It's much more clear when you have like animations and stuff. I'll tell you. So there are going to be parts where you would need to switch the video. I will tell you which video to watch, or you can just watch any video. I don't care honestly, but I will recommend you guys one animation. There's a good channel too. I will make a separate video on covering these channels. Like Shiksha House. Yeah, this one. Shiksha House. Best for NEET. That's what the channel name is, but I think. You can go here. Go on playlists. That there should be biology. Where's biology? Not MCQs. There should be separate animations. Here.
Plants and animals require nourishment
These words.
for growth.
Okay, you could go and watch these videos. They have like animations, so it's gonna help you guys a lot. Let's start now. I've been babbling for like 18 and I haven't taught you guys anything. You can skip the parts, I don't care honestly. Oh god, the condition's getting worse now. Let me get my hanky. Gonna find it. Okay. I'm really hungry now. Okay. So transforming principle. So there was a scientist named Frederick Griffith. He conducted a series of experiments with the Streptococcus pneumoniae. Well, I don't know the exact pronunciation, I'm sorry. Conducted experiments on Streptococcus pneumoniae. So, if you don't know what's Streptococcus, STRBT, wait, S. Oh, what am I doing? Strepto. This is streptomycin. It's in Streptococcus. Yeah. It's the spherical bacteria. If you don't, just in your class 11 book on page, I have the old one. In Kingdom Monera, there is Cocci, Bacilli, Spirilla, Vibrio. If you go here, bacteria around shape 4 categories. Coccus, plural is Cocci, Bacillus. So Streptococcus. Coccus basically just means, spherical. It's a spherical shape. So you can see here. This is what I'm talking about. Streptococcus is a genus. It's a gram-positive bacteria. Basically, it can get stained. It gets stained, okay. It's a spherical bacteria. That's what strepto means. And Streptococcus for pneumonia and meningitis. Meningitis, meningitis, I'm gonna explain meningitis to you because it's basically brain eating. Okay. It's gonna, yeah. It's inflammation in brain, okay. Okay. I did know what meningitis is, not exactly, but I know it was inflammation. So that's what Streptococcus. It's the bacterium responsible for causing pneumonia. 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 Okay. So he conducted experiments, so there must have been some sort of outcome, and the outcome was fascinating. Okay, he saw transformation in the bacteria. So what exactly did he do? Streptococcus bacteria are grown on a culture plate. If you don't know what a culture plate is, I'm like taking it from like basic culture. It's basically environment that we do that we make to cultivate bacteria tissues. It's an artificial media. We add nutrients to it. There, I'll show you culture plate and micro. Yeah, it's part of my. This is what a culture plate looks like. You know, you see this. We have grown these in, you know, container growing. Yeah, medium, blah 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 blah. Okay, this is what a culture plate looks like. Oh God. So he grew Streptococcus pneumonia in a culture plate. So what did he saw? He saw smooth colonies, smooth shiny colonies. Some Streptococcus produced smooth colonies while other produced rough. So this is the part from where we're gonna. So he grew. I'm gonna just write SP for Streptococcus. Okay. Yeah, we're gonna write SP. So he grew Streptococcus pneumonia in culture plate. My handwriting just sucks at this point. So, what did he saw? He saw colonies. Some were smooth and shiny. Others were rough and what else? And the stray and not shiny. Okay, there isn't a classroom. So some were smooth and shiny, some were rough. So what happened was these had the mucosa layer on them. These didn't have the mucosa layer. Or you can say polysaccharide coat. Yeah. Sorry. Well, these didn't. BC. These didn't have BC. So what happened? He took a mouse. Okay. This is your mouse. Okay. He injected this mouse with here's another mouse. He injected both of these mouses with the Streptococcus pneumoniae. This one was smooth. These ones were rough. Okay? What happened when he entered the S strain bacterium into this mouse? died. Nothing happened. He died. And the R strain one lived. Alright. S strain side. This is the R strain side. Okay. Now, what he did was he heat killed the S strain. Heat killed the bacteriums. Both. Not both, I think. Yeah, he heat killed the bacterium. The S strain bacterium. It's on the S strain side. After that, he took the mouse, injected the S strain in the mouse, but this was heat killed. He heated the bacteria, which caused it to die. And after that, mouse lived. Mouse didn't die. But what he did now was, I don't know why he did it. Curiosity. That's the main thing. You need to be curious. Now, he took another mouse. Okay? He injected the mouse with S strain. Heat killed bacteria. Okay. But he mixed this with R strain too. After this, mouse died. So there must have been something that transformed the S strain, the heat killed S strain, back into its original form and caused the mouse to develop pneumonia, and that's why mouse died. So there must have been something, because he conducted the same experiment without mixing with the R strain. But nothing happened, mouse lived. But after mixing with R strain, mouse died. So there must have been some sort of transformation that happened. So yeah, the main important thing here were heat killed S strain bacteriums, but after the mouse died, he extracted the Streptococcus pneumoniae bacterium from the mouse, and what he extracted were live S strain bacteriums. They were live. Voila. How strange. So, the conclusion of this experiment was, R strain caused some sort of transformation. Okay? R strain somehow, don't know how, was enabled. He enabled the S strain bacteria into its original form. Like it was heat killed, and it got transformed back into its life form, making it virulent. Yeah, there are two terms here, virulent and non-virulent. Is it virulent or virulent? I think it's virulent or virulent. I don't know how you pronounce it. And yeah, but the thing is, like he thought, like there was some sort of transformation, but actually, what happened was this R strain you see here, right after getting injected into the mouse, R strain was able to develop polysaccharide coat on it. Don't know how it was able to do it, but yeah, it developed polysaccharide coat on itself, and that's how and became virulent. I'm just explaining, I'm not making notes. It's just how I study. The biochemical nature of the genetic material wasn't clear, defined at this point, because all this experiment proof was there was some sort of transformation that went on. So there must have been some sort of genetic transfer or something, making the R strain turn virulent. But we don't know. After that, yeah, the biochemical characterization of transforming principle. Transforming principle. Ha ha ha. Good morning, Governor. I always wanted to say this. I wish I had a deeper voice, and I wish I was British. So, whenever I would have said this, good morning, Governor, it would have sounded a lot better. Okay, now, yeah. Interesting stuff. I'm gonna take a walk now. I don't like sitting for long periods. It's been 38 minutes. So, if you have a water bottle, drink some water. And if you don't have one, I'm giving you 10 seconds. Go to the kitchen, fill your water bottle up, drink, and get a glass of water. That's it. Okay, hydration break. We're gonna call it hydration break. I'll tell you the reference of this too. If you go on YouTube, WOD C, yeah. Okay. Oh. He hasn't uploaded a lot in a while. But if you watch any of his videos, there's gonna be a break called hydration break, where You just need to go and drink water. Yeah. So we're also gonna have a hydration break because water's good. Okay, go. I'm also going to get my water bottle. Oh, God. Oh. Okay, I'm back. I'm back. Yeah, we did get the tripod. We have a tripod now. I'm ordering like useless stuff now. I ordered a skateboard. Yeah, maybe I'll record some stuff to upload on like YouTube Shorts. Yeah, I'll go on the terrace and I'll go on the terrace and shoot some stuff. Shoot some stuff for YouTube Shorts. Maybe like if I get like a single like on this video, I'm gonna do what? I'll start gardening. Yeah, that's what we're gonna do for winter. Winter is around the corner, so yeah, we're gonna do that. Power low? What? Is my Bluetooth connected still? I don't. Okay, it's not. Oh God, it's connected. What? Wait. Where is the Bluetooth?